Okay, now we proceed to class of polymers. Okay, we classify these polymers according to how they react and stable towards heat. We have thermoplastic, thermosets, elastomer, and also natural polymers. Okay, the one that has been used largely in the example is polyethylene. Okay, so still remember what kind of um, reaction is involved in making polyethylene. So polyethylene is a thermoplastic polymer. That means it can be molded again upon heating. Okay, so if you refer to the phase diagram just now, you can see where is polyethylene situated in. And then we have thermoset. Thermoset means that once it is set into the certain temperature, it is made for end material, okay, final material, it cannot be remolded again. Why? Because they are already hardened together upon heating. So this example of thermoset is epoxy, usually used in top coat in car or on flooring in factory, because it is at least hardened. Okay, but upon time it can be corroded, not corroded, it can be peeled off because it lacks of flexibility and can crack and brittle upon physical abrasion. Okay, and then we have elastomer or rubber. Okay, it can stretch and return to original size, and because this elasticity, untreated rubber can flow when hot and can become brittle when cold, and this means it can prone to crack. That's why the rubber used in our car tire, okay, especially when the tire is the one that is fake one, tiruan, okay, it can be brittle and then it can explode upon hitting on the road. If you bought a branded one, the branded one will vulcanize the rubber by adding carbon disulfide to increase the linkage into the polymer, so that the tire, okay, can be stiffened but still preserve the flexibility and moldability. Okay, so that's why it's very important to buy a good brand of tire rather than the fake one. And then last one is natural polymer, biopolymer, such as cellulose, paper, and also cellulose acetate, the reformulated one derived from biopolymer, lignin, and also protein. So protein is part of natural polymer. Okay, in polymers, we add additive inside it. One of the additive I mentioned in the previous slide is the disulfide linkage to vulcanize the rubber. So that is one additive. And also the second additive is plasticizer, such as phthalates. Okay, the one that gives you the new car smell, because this phthalate is added um, to enhance the tensile strength, as well as to prevent brittleness in the original polymer. Okay, so this plasticizer can increase softness as well and can be applied. Okay, so this is the reason why we have a new car smell, because in the first first few days upon application of plasticizer inside polymer, okay, it will volatilize upon heating. For example, if the car is left in um, the sun outside, it can be volatilized over and over again, and when this phthalate is gone, the original material can become brittle and cracked. That's why when we see old car, all those dashboard and also steering will become brittle by time, because phthalates are gone. Also, unfortunately, plasticizer has been identified as a health hazard for children because phthalate is also used in soft plastic toy, unfortunately. Okay, we go into how polymer is processed and fabricated. The reason why we have to go into this subtopic because the physical appearance of the polymer is very important for us to classify and also individualize the evidence or exhibit that we have. Okay, same like analysis of colorants, right? The first thing that we do is to see the evidence of color under the microscope, especially if it's involving pigments. So the same thing here. Before we go further and analyze chemically for the polymers, we see what is the structure of the polymer at that time. Okay, in order to do that, we have to understand how polymer is processed and fabricated. For example, give you one situation. Suppose a body part are found in plastic bag. Okay, you know plastic bag is made of what just now, right? It is made from the LDPE, low density polyethylene. So we have to understand how this LDPE is made of. Okay, so when you have this plastic bag and then you have a suspect, and then in the suspect home you see the same plastic bag, in order to confirm whether it's coming from the same source, you see the striation pattern on the bag. The striation pattern means that the pattern of the tear lah, the koyak one. Okay, it can link to the roll of garbage bag in the suspect home. Okay, such a physical match is simple and definitive if only you know how the polymer is produced. Okay, how garbage bag is produced. Okay, it's either by film casting or drawing or molding. Okay, drawing into fiber is an example of using spinneret to produce the rayon fiber. So let us see on the film casting. Film casting will make thin films, so it is relevant to the one we talked about, the plastic garbage just now. Okay, how this film casting is made. Okay, let's say if we have the polymer solution in solution form and we have a roller, so we have several roller to make a thin film. When you see this roller over here and when you see the vaporization of solvent, you will be refreshed on the memory for the one we discussed, like paper production in the pulp production just now. And also it relates to the one we talked about, the laser jet, right? The laser jet is using roller and also some solvent vaporization. So the polymers solidify as the solvent evaporate, leaving behind the low density polyethylene or any other polymer related to thin film. Okay, and then we go to the next production of polymer. This is drawing into fiber. So refresh your memory back to the discussion about rayon and spinneret. Okay, we have a solution of polymer and then we have a spinneret over here. So this spinneret is governed by the type of holes in this spinneret here that will produce different type of final product. Okay, so what kind of spin fiber will identify the manufacturer of that kind of fiber and spinneret. Okay, this is usually used for rayon. Okay, rayon just now, right? So this can also include whether we spin it without um, lots of solvent, and also we use melt spinning. Okay, but the final product is usually different from each other because of the fiber extrusion difference. Okay, and then we have bicomponent fiber. Bicomponent fiber simply means it's comprised of two polymers of different chemical or physical properties, okay, by means of using spinneret, whereby one polymer is enclosed into another. Okay, so different kind of application is used from this type of bicomponent fiber. Okay, we have other than the common one, this is the most common design. Okay, we have something like this. When I see this, all I can think about is the microfiber duster. I don't know why, but it looks like this. Okay, and my suspicion is actually evidence from the next from the next photo over here in this kind. Okay, so this looks like a microfiber duster, and also can belong to certain high-tech mopping system. Okay, when you mop, you see that the fiber is something like different from the normal white one, right? So we have a mop like this as well. There must be different kind of application, whether to enhance the wettability of the polymer or to enhance the stability of the polymer. So different kind of application. This is the most common bicomponent polymer.